Good afternoon. We're going to wait just one more minute before we start our session this afternoon. See if we can get a couple more of the people logged in. Thank you. Okay, it looks like it's about 1 minute past the hour, so I think we'll get started. Good afternoon and welcome to today's webinar, Technology Advancements in Endoscopes, Improving Image Quality, EMI Protection, and Design Flexibility. Sponsored by the following Hiroshi franchise distributors, DigiKey, Mauser, Future Electronics, and Highland Electronics, who are authorized to sell the portfolio of Hiroshi Interconnect products. I'm Bill Kysiak, and I'll be your moderator today. We have a few brief announcements before we begin. First, this webinar is designed to be interactive, and we encourage participation in the Q&A session that will take place at the end of our presentation. You can submit your questions at any time in the chat area. Please note that we'll get to as many of the questions as we can in the time that we have left at the end of the program. However, if we don't get to your question today, someone will get back to you after the program has ended. If you want to view in full screen mode, please click on the red tab on the right side of your screen. And now for today's presentation, Technology Advancements in Endoscopes. Discussing today's topic is Joe Kawada, Industrial Segment Manager at Hiroshi. Joe is a graduate from the University of British Columbia with a Bachelor of Arts in Human Kinetics. Joining Joe will be Jeremiah Stanek, Industrial Technical Marketing Specialist, who graduated from the Illinois Institute of Technology with a Bachelor of Science in Chemistry. Additionally, Bill McKillop, the Internet Technology and Technical Support Manager at Hiroshi, who has a BSEE from Northeastern University in Boston, will join Joe and Jeremiah in the Q&A session. It's with great pleasure I now turn this special session over to Joe. Joe, take it away.
Thank you very much, Bill. So hello, everyone, and welcome to today's webinar. So we are pleased to have this opportunity today and have technical discussion with you. In today's webinar, we will focus on several technical issues that we found so far through our activities, and we'd like to discuss with you how to collaborate on those technical difficulties together. So Jeremiah Stanek, our technical marketing specialist of the endoscope market, will share our findings. So please let us start our conversation from there. So Jeremiah, all yours now.
Let me switch the screen to the PowerPoint here, and we can begin. All right, thanks everyone for joining. Today we'll be talking components inside the endoscopic system. Some of the issues we'll be focusing on are improving image quality, EMI protection, and design flexibility. So a quick agenda about today. We'll be talking about a few different types of applications like connections inside the scope, which include the processor, operation unit, and tip connections, and also different components inside the video processor system. Some of the connectors we'll be talking about are the active optical connectors, some coaxial connectors, some floating board-to-board connectors, and our NRB wire-to-board and wire-to-wire series. So let's hop right into it. So for endoscopes in the last 10 years, there's been a lot of improvements. In terms of image quality, there's been huge transcend since 2010, where we had HD 2D, where we're using about 4K resolution right now, which requires a higher speed transmissions from about 1 to 3 to 6 plus gigabits per second. And we're looking at increasing that in the future. And at the same time, endoscopes, the diameter of the scopes itself are getting thinner and thinner to be as minimal invasive as possible. But in the future, we're looking at hitting 8K resolution or anything higher than that in the next 4 to 7 years. And some of the technologies that we've seen that are coming up are endoscopy VR simulations, where you have VR simulators that are being developed to train doctors. We have disposable endoscopes that are used for single patient use to lessen the risk of cross-contamination, and even capsule technology, where these are pill-sized devices that are swallowed by a patient and they record images as they travel through the body. Technology that's coming out in the near future, new technology, you're going to need some or more transmission speed. These include high-speed optical devices, your high-speed board-to-boards, hybrid I/O connections. Ones in the endoscopic system, the two main ones are the video processor itself and the endoscope, where in the endoscope we'll be focusing on the camera head and the light source sections. So there's two main types of endoscopes. We have the rigid endoscopes, which include a thinner type and a thicker type. And so the parts of the endoscope we'll be mostly talking about today are the electrical system, so where the cable with video, light control, and remote switching from the video processor is connected, and also the light system, which is where the connector is inserted into the light source and directs light through the fiber optic to the insertion tube. So as you can see in the images, we have three main components that will be focused: the operational unit and the terminal connection. So let's start off with the process. What are some of the issues that we see in endoscopes? Number one will be space restrictions. So since everything in technology is getting smaller, from consumer electronics to industrial to even minimal invasiveness is one of the key things. There's a lot of pros to the minimal, offering less pain to the patient, shorter, reducing scarring, or even just for the patient after post-op. We have the issues of custom endoscope design, where endoscopes there's no one template for the endoscope design. There's no one template for the terminal connection. There's a lot of different variations out there, and that requires unique solutions depending on the design itself. And finally, we have the high operating temperature. So the high operating temperature, one good example is the autoclave sterilization used to kill harmful bacteria. That's usually done by using high pressure steam into a chamber containing the objects that needs to be sterilized. So therefore, these devices must be able to withstand a pretty high temperature in the range of 100 or most likely 125 Celsius without any damage or deformation. So it's pretty tough to find components that can handle this temperature without losing connectivity or having any types of quality issues. So how can we find solutions? What kind of solutions are out there to help minimize these issues or help at all? So the first I want to talk about is our DF40 series. So some of the issues that we talked about on the last slide are compact and having variations. So the DF40, as you can see in the bottom here, we have a lot of different stack heights ranging from 1.5 millimeters to 4 millimeters in height. So a lot of variation in that, while also simultaneously having a wide range of pin counts from 10 to 120 positions. So that solves this, that helps with the space restrictions and variation components. Well, how about the heat resistance? The DF40T is our high automotive grade version of the DF40. So whenever you hear automotive grade, usually what I think of is being robust and high temperature, because automotive has very strict requirements. So our DF40T actually can withstand 125 Celsius of high operating temperature. So it can help withstand that autoclave high regulations and requirements. Not have any types of quality. with the DF40 size, but the BM28 is even smaller. 0.6 millimeters in height. So compared to about 1.5 millimeters from the DF40, this is smaller in terms of height and being low profile. And usually very small connectors, there might not be too many variations, or the BM28 actually packs quite a punch with two power signals that have 5 amps of current each. So they can handle some power capabilities while simultaneously having a lot of different pin counts from 6 to 60 in terms of signal connections. And in terms of keep pushing the technology, Hirose developed the BM46 to keep pushing the technological boundaries. So the BM46 is a multi-RF board-to-board connector that'll develop for your next-gen high-speed communications. So the conventional solution is to have one board-to-board connector plus 2 RF connectors. But the BM46 combines all those into one and saves about 66% in terms of overall size by mixing it all into one while still having the very low stack height of 0.6 millimeters. So this connector is great for the space restrictions and having a lot of different variations depending on your design needs and space restrictions, or depending on how many signals you need in your board-to-board connector. When we talked about the processor and operation unit, how about a terminal connection? So the terminal connection sees a variety of issues, unique issues as well. And the first one is increasing number of pixels, higher resolution. So currently, we in early 2000s we saw the first HD that pretty much changed the concept of endoscopes altogether. And back then, that technology was cutting edge at the time, allowed to have better and more accurate diagnoses. And times have now looked back since you can see a better image quality that provided a whole new amount than on the screen itself. So from your HD to your 4K into the future, your 8K needs, those needs are coming, and that needs are for higher transmission speed and other technological advancements. We also see video distortion caused by EMI, and due to EMI, some images can't be recorded, and there are concerns that this has led to some problems of the endoscope quality being missed and diagnoses being missed at all, which is an awful thing. But having a noise-free device is vital to keeping quality and signal reliability to reduce any chance of these issues occurring during the procedure. And finally, our last issues are wire and cable difficulties. Like I mentioned, since things are downsizing now, these shielded cables are pretty hard, wide, and difficult to bend. And with these size restrictions and trying to keep the board as small as possible and these endoscopes as small as possible, this could lead to some problems. So these are some of the issues we've seen in the terminal connection. And I want to start off with one of our connectors that is a good source to answer all three of these questions. All three of these issues is our BF4 series, our one-way communication active optical connector. So our BF4 series actually is an E to O, O to E, what we like to call. It's an electrical signal to an optical signal transferred through an optical fiber and then converted back to an electrical signal. So what are the pros of this? In the upper right-hand box I highlighted here, you can see that the BF4 has noise resistance due to having this optical fiber. It has a very low power consumption, speed capability of 6.25 gigabits. But earlier, 6.25 gigabits per second. But how about the future? How about high resolution see in a couple years forward or in the future? So that's where I want to get into the development product, our BF10 series. So our BF10 series is pretty much, I would like to call the twin brother of the BF4, or the smarter twin brother, as it has a higher speed capabilities of up to 12.5 gigabits per second. And the one way we utilized to get this higher speed was a difference in its internal semiconductors into the system. But overall, the two connectors are pretty much roughly same in size with similar internal components. But with that internal difference in semiconductors, that allows it for the 12.5 gigabit. But it still uses the optical fiber cable that allows for very flexible and a lot of bend radius. So if you do need any types of testing in terms of signal speed, signal integrity, wire bending, we have a lot of different testing just to see if it meets up to your design requirements. So we talked a little bit about the BF4 and the BF10 optical connectors, but what else is there out there from Hirose? So for the optical development, since the BF4 and BF10 are one directional, we do have bidirectional series from the IR2 and the FRM series. So these are bidirectional optical connectors for your internal and inter-device wiring. These connectors incorporate actually two of the BF4 connectors inside the plug that enables that two-way connection. And it also allows for long distance transmission, isolation and noise prevention, and even has a LED connector confirmation built into the plug, so you know it's fully made and operational. And we also have some other optical connectors, like the LC and SC optical connectors that can be used as one way, or you can even add on to our UJ series, which can be seen here as a very small, very compact inline optical connector. So overall, this is some of the optical connector portfolio that Hirose has. There are new developments coming up, and we always love to hear your engineering capabilities or design needs that you see out in the marketplace as well to develop any types of future connectors. So that was the endoscope portion of the presentation. We talked about a few different issues and the different components in the endoscope itself. But now I want to transfer over to the video processor system. So as you can see in this image, the video processor structure has a lot of different components onto the board itself. So some of the components are the power supply and the memory board connection. We have the board-to-board connection, so your main board to display, or your main board to your endoscope board connection. And finally, your interface connections, which includes the display and network interface. So all these connection points include a wide range of solutions that are available out there, and also there's a wide range of issues that can occur. So some of these potential issues that we've seen: transmission characteristics. With many of these high-speed images and high-speed connectors and components on the board, this increases the amount of crosstalk and thermal noise that may cause unreliable signals, or EMI. We also see connector breakage or solder cracks due to having multiple board-to-board connectors on a single PCB. Tolerances stack up, and any types of misalignment can cause contact damage or connector damage or different component damage. We also see surrounding heat dissipation. Since there's numerous components on the board, overheating of components is a real concern. And finally, since the PCBs and the board and the endoscope itself is getting smaller and smaller, these smaller units eventually run out of space if you're using a lot of components. So space for wires and cables is restricted as well. So one of the solutions I want to talk about is our FX23 board-to-board series. So this is our power signal hybrid connector, where it has 4 designated pins for your power current capabilities. Those 4 power pins can reach about 3 amps per pin, while still having 20 to 120 signal pins, depending on your design needs. It does have 8+ gigabits per second speed, so it allows that high-speed transmission. But the thing I want to talk about most is the floating feature. So the floating feature addresses your connector breakage concern. There's a video on this slide that best illustrates it. So as your mating connector, the floating feature actually gives the connector a little leeway or wiggle room, so it has a 0.6 millimeter of adjustment to try to prevent any types of connector damage or contact damage into the connector itself. This really helps when you're using multiple board-to-board connectors on a single PCB, as you can see in this video below. While mating 4 FX23s with this floating function, it's easier and can decrease any type of tolerance stack up that you may see to prevent any type of contact damage or connector damage itself. The next series I want to talk about is our IX Industrial. I'm sure everyone here, or mostly everyone here, is familiar with our RJ45 connectors that's been around for decades and decades now as your primary Ethernet connector. But since is a repeating topic, since things are getting smaller now and space saving is a real issue and concern, our IX Industrial is the next generation Ethernet connector that's about 75% smaller in size than the typical RJ45. And you can see in the upper right-hand corner the two size differences between the receptacles itself, where the IX industrial receptacle here is is on the left here, while the RJ45 is on the right. So not only is the connector smaller, but I know in my personal use and in professional use, I had an RJ45 that the connector broke off and I'm left with a connector with no lock or just a simple friction lock that doesn't hold too well. So the IX Industrial actually uses a double latch system where the positive lock is pretty much embedded into the receptacle, the plug itself, where into the body of the shell. So it kind of prevents any type of lock damage or breaking of any lock. So it gives you the quality robustness of a connector. So these kind of help solve the transmission characteristics issue, and especially the space and wiring restrictions that we have in our video processor system. And as you can see here are some of the different interface connectors that we have. I discussed about the IX Industrial, which has 10 gigabits per second capabilities, or up to Cat6a capabilities. We also discussed the BF4 IR2, which is our bidirectional optical connector that can go a little bit over 6 gigabits per second. We also have other standard connectors like our MF11 series, which is IP67 proof, and also our BNC75, which is our coaxial cable that enables 4K equivalent signal transmission to help for your resolution needs. And here, this slide, I want to just go over the BF4 really quickly again. So before we talked about the different specs that it has, but here I want to emphasize the size difference of the BF4 versus a conventional system using an LC connector. As you can see in the image on the right here, the BF4 is dramatically smaller in size while still having the high speed capabilities of 6.25 or the next gen model over 12 gigabits per second, while remaining noise isolation and lower power consumption. So it's really helpful connectors, especially in your endoscope or video processor board. And here, since the BF4 is noise-free, I want to mention some of our flex connectors that are shielded. So we have front flip robust EMI protected flex connectors like our FH41 and 48 here, which can handle about 8 gigabits per second. We also have our one action lock series, which the best way to put it, the one action lock is when you can insert the FPC cable without lifting the actuator to an open position. So you can insert it easily. I think it's best described by a video, as I will show here. So I like to compare it to the airplane seat lock. So for the airplane seat lock, you could just insert the cable into the lock itself and it's fully locked. And then when you want to release, you lift the lock itself and pull the cable out. Exactly the same for this FPC connector. It does have a very low insertion force while remaining the high retention force. And there's FPC tabs on the side that help fully capture and ensure a robust connection. And finally, I want to talk about some of our wire-to-board connection. Since power capabilities is a need and having high operating temperature is also a need, you need a connector that has some current capabilities. So Hirose is known for their micro connectors and their flex connectors, but we also have high power connectors. Our DF33 is our 5 amp small low profile DF wire-to-board connector. We also have the DF63 series, which is kind of the mid-range 12 to 15 amp connector. It comes in a wide range of variations of wire-to-board. You have wire-to-wire, waterproof, and even a vertical insertion option. So it's good for your mid-range power capabilities. But we also have products that go into the high power of 60 plus amps, our DF60. So our DF60 is our wire-to-board or inline connection. It's actually about 15% smaller in terms of size of its overall competitors in its size of wire-to-board and 60 plus amps of current. It's a very small, compact connector. So we call this the Energy series, which has 3 main advantages: small overall size, positive lock for your robust lock, and also key coding. So if you're using multiple of these wire-to-boards, you can't insert the wrong plug to the wrong receptacle. And finally, they're all high current and high voltage connectors. And finally, for a quick recap, what we covered today, some of the key components in the endoscopic system, like the connections inside the scope, and also the different components in the video processor system. We also talked about quite a few connector styles of active optical connectors like the BF4 and BF10, some coaxial connectors, our floating board-to-board FX23, and some different power wire-to-board connectors like the DF60 and DF63. So thank you for taking the time of your day for this presentation. Now we'll switch over to our Q&A section, and if you have any questions, please put it in the chat area. Thank you.
Great. Thanks, Jeremiah. We'd now like to open it up for questions. If you'd like to ask a question, please enter it in the chat section of this website, and we'll be happy to get it out to the panel. I'll give you a second. Oh, I think we've got one in here from that was submitted during the presentations. Does the BF10 support bit encoding? Panel?
Sure, Bill. I'll address that one. Both the BF4 and the BF10 support 8B, 10B bit encoding, but the BF10 specifically below 8 gigabits supports 8B, 10B encoding, and above 8 gigabits up to 12 gigabits supports 64, 66B encoding.
Great.
Good
Thanks,
question.
Bill. Thank you. And then can a BF4M be harnessed to a different type of a connector?
Yes, we do have BF4 variations. The typical way is to have both sides of the BF4, the TX and RX side, but we have another variation where one end of the BF4, one end could be the BF4, and the other end could be a conventional optical connector, maybe like a SC or LC inline connector. So Terossi offers both of those harnesses.
Okay, and then a follow-up to that question, which is where can we find cables for the BF4M?
That's a good question. And since this is a unique connector,
Jeremiah, you froze up there. You might want to back up. Or does anyone else, any of the other panelists, can you answer that?
Yes, we can. Actually, we do the assemble by Hirose. So BF4 is a very unique connector, and then cable termination requires some special scale. So the cable assembly itself is supported by Hirose, and then you do not need to go to any cable harness maker for the assembly of a BF4. And then the shortest length would be like 45 millimeter, and then up to 5 meter. But any other lengths you'd like to go with, just let us know. We can discuss, go from there.
Okay, great. So Hirose does supply those directly, not through a harness manufacturer, correct?
Yep. Correct.
Yeah. Okay. Jeremiah, it looks like you froze up. I think you're back now. Are you?
Yes.
Yeah. Great. Okay. Good. We've got a question here outside of the the optical stuff, which is, can the IX be used for PoE, power over Ethernet?
Yes, we actually have a few different testing done for the IX with PoE, so it can handle the latest IEEE 802 standards, and those test reports are available as well.
Great. Okay. Back to optics. What's the diameter of the microfarrel used in the UJ series?
Oh, good question. You would have had to read quickly on that slide to catch it. The diameter of the microfarrel is, I believe, 80 microns. I can double check that here. Yeah, 80 microns.
Okay, great. Thanks, Bill.
Yeah.
Let's see if we've got a couple more coming in. We might, let's hang in there a second. Oh, here we go. What's the power consumption of the BF4 OE connector system?
Okay, so the BF4 comes in two modes, a dual voltage supply mode and a single voltage supply mode. When it's in the dual supply mode, it draws 80 milliwatts max approximately, but in the single voltage supply, power supply mode, it draws about 120 milliwatts.
Okay, thanks, Bill. And then does Hiroshi offer any locking board-to-board connectors?
I'll take that one, Bill. Yes, we do have our low-profile DF40, which I mentioned in the presentation. There's actually a locking option. For that connector, it incorporates a lock that firmly holds it in place, and it's pretty easy to unmate, as there's a little lever on the connector itself that you tilt that and it comes right off. So it's easy to remove, but while still holding a very strong lock.
Okay, good. Let's see. I think that might be, oh wait, we got one more here. Is the IX Industrial standardized through any standards organizations?
Yes, the IEC. Do you want to go ahead and take it, Jeremiah?
Oh, sure. Yes, the IX is actually standardized by the IEC standard. It also certifies as a standard connector for GigE Vision, which is a global camera interface standard.
Great. Okay. I think that's the last question. Oh, go ahead.
Let me
Sorry,
piggyback on that one. That IEC standard is the 61076-3-124, if somebody wants to look it up.
Okay. Thanks, Bill.
Sure.
And I think that's about all the questions we had. So last call for any questions. Again, just put it into the chat area. I think that might be about it. So thank you all for joining us today. We hope this webinar was informative and you gained some ideas to help you with future endoscope designs. And don't forget to follow Hiroshi on LinkedIn. Have a good day and stay safe. Goodbye.